Assalamu alaikum and good afternoon for everybody. My name is Guga. My surname is Arbarov. I'm from Turkmenistan. I'm doing chemical engineering program, first year, second sem. Today I'm going to analyze, I'm going to present the Dr. Lukman's experiment on the effect of oscillatory battle tube apparatus on the deposition of paraffin wax. So, firstly, I'm going to briefly explain the outline of my presentation. Introduction, research objective, ways to overcome the wax deposition. Introduction to OBTA, link between the research work to fluid mechanics principles, and future and further research, as well as the industrial applications and conclusion. So, we all know that the paraffin wax deposition is one of the biggest problems faced in the petroleum industries nowadays. Actually, we can explain the general idea like this. Let's say it's the pipeline, and the crude oil must be transferred to the onshore after it's drilled in the wellbore in the offshores. So this pipeline actually is located under the water. So the oil enters the pipeline at 60 and 70 Celsius degrees, and the external, the temperature of the water is 4 Celsius degrees. This is the seawater. So due to the temperature difference, there will be cooling of the crude oil. Because of the cooling of crude oil, there will be heavy hydrocarbon precipitates in here. They will be narrowing the pipe inside because they're heavy hydrocarbons. Paraffin wax actually means paraffin is actually the common name for alkane hydrocarbon, and paraffin wax is also heavy hydrocarbon with a 20 to 40 number of carbons. So this narrowing in the pipeline actually decreases the flow rate, and this can end in the blockage of the pipe. So this is a very big problem. Next slide. So the research objective of Dr. Lukman was to investigate the effect of applying oscillatory motion on the wax deposition in an oscillatory battle apparatus. So can oscillatory motion break up and suspend the deposition in the pipeline? This is where we're going to make research. So as I mentioned before, the deposition of paraffin wax is a major problem in the petroleum oil industry. So people found many ways to overcome the wax deposition. These ways are using high velocity flow, inductive heating of pipelines, application of glass inner layer, and addition of chemical glass inhibitor, use of exothermic chemical reactions. Other than this one, Dr. Lukman's and his team, they offer completely different way of mixing, completely different way of reducing the deposition of wax. This OBTA, the oscillatory battle tube apparatus. This is governed by two dimensionless groups. The first one is oscillatory Reynolds number, which controls the intensity of oscillation applied, and the Strouhal number, which is the ratio of column diameter to the stroke length. So from here, this is the experimental setup of OBTA. We see we have two baffles here, and these are the water passes, because as we know, the oil enters the pipeline with a higher temperature, and the sea temperature is 4 Celsius degrees. So these two passes will control the temperature and the cooling. So this is how the experiment setup looks like. So there's the motor which will control the oscillation up and down. So there are the baffles and all. So we directly jump to the link between the research work of this work to the fluid mechanics. The first thing I found is that the properties of fluid, Newtonian and non-Newtonian fluids. As we know, when oil enters the pipeline, it enters with a 60 or 17 Celsius degrees. It's hot. And its viscosity is constant at that time. It's a Newtonian fluid at that time. But later on, due to the cooling of the crude oil by the seawater, the viscosity of the crude oil increases, so it becomes like a gel. That's why it no further obeys the rule of Newton's law of viscosity. So after that, it becomes a non-Newtonian fluid because of the gelation of the crude oil. So second link which I found was fluid mixing. Last time we had an experiment, fluid mixing. So there we use the baffles. We see the difference of mixing by using baffle and by using without baffle, by not using the baffle. So in here, in this OBTA, we have two baffles installed in the tube. So these baffles, there are very good advantages of this using these baffles. They increase the intensity of mixing. So it's very good with the baffle here. So the third relation I found is that Reynolds number from chapter 4, incompressible fluids, the laminar and turbulent flows. In there, actually, both formulas that I used, the formula that is used in this experiment and the formula that's used in our fluid mechanics tutorial lectures, both the formulas are similar, actually the same, but in the one which we use in the turbulent and laminar flow, we use the velocity, the fluid velocity in the straight pipe. But in here, in this formula, in the Reynolds number, we use the oscillatory number. So I can actually write here the Reynolds number is 2 pi x over viscosity. This is the one which was used in the experiment in this work. So this is actually the oscillatory velocity. And the other one that we use in the fluid mechanics in our lectures, that formula is velocity times density d over viscosity. This velocity is actually the velocity of the flow flowing straight the pipe, but this velocity is the oscillatory velocity. So that's the link I found from here. So now I'm going to talk about the future application. So as you know, that this experiment is carried out in a batch mode, whereas the oil pipelines are continuous operations. Therefore, this application must be applied in a continuous flow system, because this work is actually found is used in a batch mode. But we know that the oil always keeps flowing from the pipelines from offshore to the onshore, so we must apply this in a continuous flow system also. So we also can design different baffles, because as you know, we use two baffles in our OBTA apparatus in the setup. So we can design different kind of baffles to have an intensive fluid mixing, So the third one will be the effect of using other oils such as octane and decane. So as a conclusion, we have results. From the results increasing in the oscillation frequency, we came to know that when we increase the oscillation frequency, there's a decrease in the deposition of paraffin wax, and from the preliminary results, increasing the oscillation amplitude also generally decreases the amount of wax deposition. So, thank you very much. This is the end of our presentation.